Still not sure. I like Windows 10 better than my old system, but I guess I have to. I don't have any choice. GoToMeeting wasn't being supported by my old system. Okay, so we're supposed to graph these. Can you read this, or do you need me to blow it up a little bit?
If you could blow it up a little bit, that'd be good.
Okay. Okay. All right. Actually, I'm going to have to go down a notch because I can't see that fourth one. Where do you want to start here? I don't know how much of this you've done. What, if any, is giving you difficulty? You want to start with the equations, or do you want to start with the inequalities?
Start with just equations.
Okay, let's do at least one equation. And we'll do come on. Pen, draw, y equals 3. All of these are pretty similar. For me to graph that, what do I need to do?
You'd need to distribute the 1/3.
Right, okay, good. That's a good first step. So what's the next line?
1/3 x, y plus 3 equals 1/3 x minus 2.
Okay, next step, next line.
Subtract the 3. So you'd have y equals 1/3 x minus 5.
Now we have it in y equals mx plus b format. Where do I start?
Plot the y-intercept, which is -5.
Now what?
Then use the m, which is the number before the x, which is the slope,
Okay.
to graph out your line. So you'd go rise over run. Rise is 1, run is 3, so you'd go up 1 over 3.
You say over 3, which way over?
To the right.
Okay. You can go either way, just make sure that when you're done you have the right sign slope. In other words, that is a positive slope. Because I could also have gone down and left.
Yeah.
Alright, I don't see you having any problems with these. Any of the first 3. Let's look at linear inequality. Hold on. Said inequality, and I write it that way. What are we going to do here?
What you do is you're going to graph your line, and then depending if it's the value of 1/4 x plus 6 is greater than or less than, you would shade an area above or below the line. Since it is less than y, you would shade below the line.
Okay, let me go ahead and graph it. Is it a solid line or a dotted line?
Dotted line.
So it's the only axis we care about is the y-axis. In other words, even if I had something that looked like this, where it would be hard to say up or down, hold on. If I had some, I had something like this, and that's y is less than or equal to, say, minus 100 x plus 1. Okay? Now, if you want to figure out which side, it's tempting to look at that and think left or right. But don't make that mistake. In other words, when y is on the left side of the equation, the only axis that we care about is the y-axis.
Mm-hmm.
We're going to find a point on the y-axis that is less than or equal to the line. So any point I find tells me which side to shade. And it looks like I'm shading the left side, but I'm really shading the underside.
Mm-hmm.
So let's take a little bit more difficult one. Also already in MX plus B format. Hold it. Let's go really difficult. I know you know how to do these. These are going to be a piece of cake for you. There is one on here though that's a little different. The last one. It doesn't matter what that says. X minus 3y is greater than or equal to 2. I think it's a 2 if my memory serves me correct.
All right, all you need to do is subtract the x divided by -3.
Okay, so we end up with what?
You would get y equals
It's greater than or equal.
greater than or equal to.
Let's do this one step at a time. Now I'm going to divide by -3, so what's the next line read?
Y is greater than or equal to.
Whenever you divide by a negative number,
Y is less than or equal to.
right. That's the biggest difference between inequalities and equations. So you end up with minus 2/3. What's the rest of it?
Plus 1/3 x.
And then switch those around so that it's in MX plus B format.
Mm-hmm.
And then graph it as an equation and figure out which side to shade. I'd like to find one that challenges you a little bit. Can you see any? Here we go. Oh, it was 6, not 2. Do any of these look like they would give you a problem?
No.
Okay. I have an interesting geometry problem. You want to look at it?
Sure.
If you didn't have anything, I was going to... Oh, there were actually 2 pages of this, weren't there?
Mm-hmm.
Maybe we better look at the second page before we look at my interesting problem. This looks like the same page.
They look very similar, but they might not have the same stuff on it.
Well, it looks identical to me. Hold on a second. I think I maybe have my other problem on there. Actually, I can draw my other problem. So, oh, it is different. I can see right here that it's different.
The layout is just the same on both pages. It's just different problems.
Well, it's the one on the right. Maybe we ought to look at this. Hold on.
No, it's just graph. That's just graphing linear functions. And then x plus b.
Oh, this one is?
Yeah, that's all it is.
So there's nothing special about it?
No.
Okay. You know, not any problems with it? Let's have a look at my rather interesting problem. I think I can draw it. From an honors geometry course. It's an extra special bonus question. The area of, these are 4 equal circles.
Mm-hmm.
The area is minus 1 plus root 3 of each circle.
Okay.
The area of the rectangle. There's a lot of things involved here. That's why it was an honors geometry bonus question. But nothing that you don't know. You can figure this out.
Well, if you can figure out the diameter of one of the, because all the circles are equal, right?
Correct.
If you can figure out the diameter of
So let's do it. Area equals pi r squared. Area equals pi r squared. They're telling us the area is minus 1 plus root 3. Oh, excuse me, times pi. And it's almost always times pi. It would be difficult to have a circle where pi was not in the answer.
Yeah.
So the pi's cancel, and we have r squared equals to that strange looking thing. Now,
Okay.
that is a positive number.
Yeah, so what you can do is square root, or go ahead and do square root that.
Let's do it a different way, just to get you thinking. How many r's is that?
4.
Okay. Well, we know what r is going to be, but you're going to notice something by the time we progress through this problem. Now, the difficulty is this distance right there.
Mm-hmm.
We certainly know that it's at least 4r, right?
Mm-hmm.
But what's the distance between this point and that point? How are we going to figure it out? Let me erase something here. Took me a while to see it. In fact, the student gave it to me in real time, but I was having so much trouble figuring out how to draw these circles that it wasn't until the end of the session that I figured out how to do the problem. Put centers on these circles, and I will give you the hint that her teacher gave her.
Oh, okay.
What kind of triangles are those? Let's take the top one only.
Wouldn't that be a right triangle?
What's the length of this side right here in terms of r?
2r.
How about this side?
2r. Oh.
Now what kind of triangle is it?
It's an equilateral.
Okay. So, if I can figure out that distance there, which is this distance here, this is the same equilateral triangle down there, so I'll add that height of that equilateral triangle times 2 to get the distance between there, and then I will add 2r to it. So let's take this triangle right there. What is the height of that triangle? Based on what we now know is that that's a 60-30. Whoops.
That would be r root 3.
Good. Root 3r. Okay, so that's root 3r, because this is a 1 square root of 3, 2, 30-60 triangle. So now this length, or this height, let's put it over here, is what?
Height is going to be
How far is it from here to here?
that's going to be
That's R.
2.
That's R. From here to here is R.
Oh, that's a rate. Okay.
And then from here to here is root 3R, which means from there to there is 2 root 3R. So I got 2 root 3R plus 1 more R. So that's the height. 2R, well, and in fact, let's do a little algebra here, and keeping with the spirit of the lesson, and factor out an R, so we can write this thing properly. It's 2 plus 2 root 3 R. Correct? That's the height?
Yeah.
Now what's the area of the triangle? Or not the triangle, the rectangle.
It would be 4 by 2 plus 2 root 3R.
So 4R times that, what's that answer? Leaving it in terms of radicals.
You'd have 8 plus, or 8R plus 8 root 3.
You can multiply the numbers and then the R's. You get the same answer. Okay, so it's 8 plus 8 root 3 times what?
Times R times R.
Times R squared, right? In other words, if I multiply this R times this R, that's R squared. If I multiply the 4 times what's in the parentheses there, it's over here. So this is the area of the rectangle. And now notice a nice thing happens. We never actually had to solve for R. We solved for R squared. And that's all we need. Which is nice because no part of me wanted to take the square root of that strange looking thing there. I would have the square root of a minus 1 plus the square root of 3. I mean, that would be mathematically valid. In other words, indeed, R is equal to the square root of minus 1 plus the square root of 3. There's nothing that prevents you from having a radical inside of a radical. Okay? But it's kind of messy looking, and it's not anything that you've ever seen before. However, because we end up with R squared in our answer, we don't need R. We only need R squared, and R squared is that. So my final answer is going to be 8 plus 8 root 3 times minus 1 plus root 3, which is R squared. And then, of course, we would want to multiply that out and distribute and gather like terms. But how good is this problem? I mean, this is a great geometry problem because it talks about circles and triangles and equilateral triangles. And then there's some rather hefty algebra in it.
Mm-hmm.
So I thought you'd like it, and you did.
Yeah.
You did good on it, too. You probably should be taking honors geometry. I don't know. Are you still getting an A or in your geometry?
I got a really high C on one test, and it brought me down from like an 85 or an 86 down to a 78.5 for some reason.
Uh-oh.
I was really pissed.
Okay.
Well, I'm currently bringing that up.
Yeah, that'd be a shame for you to get a C. I mean, you got more geometry skills than almost any of my other students. I'm surprised you're not getting an A. But figure out what it is you need to work on and bring it to our sessions.
Yeah, we'll do.
Bring your weak points, not your strong points. Students tend to want to do their strong points, but you're better off doing your weak points. If you want to improve your game at anything, whether it's golf, tennis, or math, you work on your weak areas. Although you're probably in pretty good shape with this algebra because you ended algebra strong, but it's also been 6-9 months since you had any algebra really. So that's why they usually spend a couple weeks to a month at the end of geometry reviewing algebra, is because people really need it by then.
Mm-hmm.
All right, Cole. I will let you go, and I will talk to you. Still Monday at 3:30, or is that changing fundamentally?
Monday at 3:30.
Okay.
Still Monday at 3:30. I just had something come up.
Talk to you next Monday.
Like next Monday.
All right. Bye-bye.
Bye-bye.